doing? Good day, geometry. We're going to briefly review our rules for simplifying radicals with exponents. Before getting to the rest of the page, I don't remember how far we got the last time, but we'll finish this up and possibly, if the stars align, get into 61 part 2 today. So basically, in this chart here, where are the perfect squares? What are the perfect squares, Caleb?
2, 4, 6.
Right. Every even-powered exponent is a perfect square, right? Because the rule for simplifying it is just divide by 2. You know, what times itself is x squared? X times x. That's why the root of x squared is just x. What times itself is the root of x to the fourth? X squared. That's why the root of x to the fourth is x squared. What times itself is x to the sixth? X cubed. What times itself is x to the eighth? X to the fourth. So any even power is a perfect square. And the rule to simplify that is just divide by 2. Okay. When you have an odd power, the root of any variable can't be simplified because we don't know what that variable is. Root of x. But something like the root of x cubed, we subtract 1, essentially pull out a root x, so that we're left with an even power. And that's where we would get the root of x squared times root x, or x root x. For x to the fifth, we would pull out or subtract a root x, giving us x to the fourth, or x squared root x. Right? Subtract 1 for x to the seventh, that would give us x cubed root x. So for an odd power, you'll always have a root x, or root y, or root n, or whatever, but then subtracting 1 gets you that even power you can then divide by 2. Okay? So that's a recap of what we talked about last week. Then we got into some of this stuff here. Like I said, I don't remember how far we got, so let's kind of start plowing through them. What's the root of x to the 12th? Anybody? X to the 6th, right? Divide that 12 by 2. It's a perfect square, and we get x to the 6th. Because, and again, the reason why here is because x to the 6th squared equals x to the 12th. We just finished a unit on taking, powers to powers here. X to the 6th squared, those powers be multiplied, you get x to the 12th. So to undo that, we take the root, and we're back to x to the 6th. The root of y to the 9th over 49. This is the one where you can split this up into the numerator and the denominator separately. Enjoy the next 15, 20 minutes, because after that, then denominators will not be perfect squares anymore. But for the time being, it's nice. Root 49 is 7. How does root y to the 9th simplify to be? Peter? Y to the 4th root y. It's an odd power, so we know we'll have that root y. Subtract 1, 8, divided by 2. That's where the y to the 4th comes from. Root of x to the 5th is up there. We already did that one. Root of x squared, x squared root x. And root of x to the 14th, anybody? Good. X to the 7th, yeah. And I think this is where we left off here. Actually, I'm pretty sure, right around here, because we started talking about what do you do when you've got more than just a variable, when you have a coefficient there also. And similar to a fraction, you would split this up to be root 8 times the root of x squared. And simplify your coefficient, simplify your exponent, put it all together. Or simplify your variable and put it all together. The root of 8, we can break that down and be root 4 times root 2. I remember doing this now. Yes. 2 root 2. And then the root of x squared is a perfect square. That gives us x. How do we go put this all back together here? Because there's got to be a nice, neat answer when we're all done. There's got to be a certain order to it. Caleb?
Would it be 2x and then like the square 2?
2x root 2. Everything outside the root stays outside the root in the front, almost like a coefficient. Can we put the math packets away, please? It's pretty obvious when you're just kind of, I'll say it, copying. Okay? And then whatever's under the root, we keep it under the root at the end. Okay? The root of 15x cubed over 4y squared. We can split this fraction up to be the root of 15x cubed over the root of 4y squared. Simplify each separately. Our denominator is still a perfect square here. We have the root of 4, which is 2, root of y squared, which is y. Gino, yes? Yes, the x root x. Can we simplify root 15? No. So we have an x out in front and then root 15x under the root. Okay. Did we get this far? This still, you already have stuff filled in for this? Those of you that didn't think it was homework and were frantically filling stuff in earlier?
Oh, yeah.
Oh.
Yeah, I remember that.
Oh, you remember that. Yeah, it was like 2 minutes ago. Yeah. The root of 32x to the 7th, we can split this up into be coefficient and variable. How do you simplify root 32? Deal with each one separately. Peter. Root 16 times root 2. You could also go root 4 and root 8, but remember, since 4 is not the largest perfect square, you have to simplify that 8 further. So it's just easiest to get that largest perfect square right off the bat. And how does root x to the 7th simplify to be? What do we do to simplify root x to the 7th? Drake? X cubed root x. Yeah, where that comes from is we pull out that root x, essentially subtracting 1 from 7 to get that even power. Root of x cubed is a perfect square. So we get, root of x to the 6th, the perfect square, which is x cubed. And then we have our root x. Put it all back together. What's outside the root is together outside the root of 4 and x cubed. What's inside the root, 2 and x, stays inside the root. Okay. We're going to pause the video here, and I'm going to have you do the rest of these 5 on your own. There are some that you'll notice have more than one variable. That's okay. Like for this first one, you'd have root 44 times root x squared times root y to the 5th, right? Break them all up, simplify them each separately, put it all back together when you're finished. So we'll pause. We'll come back briefly. So long for now. Oh, wait. I don't know what's happened. Okay, I think we're back on. Okay, anyway, that may have recorded all or some of that exchange. I'm not quite sure. Well, you'll have to watch and find out. And don't forget to like and subscribe. So the first one being a fraction there, like we said before, deal with your numerator and your denominator separately. Okay, your denominator is still a perfect square. Last time that'll happen. So you have the root of y to the 4th, even power, divide by 2, and we get y squared. For the root of 25x to the 5th, the 25 is a perfect square, so we can simplify that to be 5. And then the root of x to the 5th, we get that x squared root x. So 5x squared root x over y squared would be your simplified expression. Okay. The bottom row, when you've got coefficients, multiple bases, break them up, simplify each of them separately, put it all back together. So root 44, you probably simplify that to be root 4 times root 11, which gives us 2 root 11. Root x squared is a perfect square. That gives us x. And root y to the 5th gives us root y to the 4th times root y. We subtract 1 to get that even power. That simplifies to be y squared root y. Right? Put it all back together. Everything outside the root stays outside the root. That's our 2, our x, and our y squared. Everything under the root stays under the root. That is our 11 and our y. These are once you get it, I won't say they're complicated, but there's a lot of steps to them, a lot of opportunities to make a mistake. Okay? You can make a mistake with division. You can make a mistake with exponents. There's a lot of opportunities. So check your work carefully. Show your work. Check it carefully so you don't make any oopsies. Happy accidents if Bob Ross were teaching this class. Yes?
So you're saying we should concentrate.
You should have heavy concentration at all. Constant concentration. For sure. Continuous concentration. Okay.
Consecutive right answer.
There it is. All right. 3, 2, 1. You are quiet. Next one, root 18. We can simplify that to be root 9 times root 2, or 3 times root 2. And then each of our x cubed, this is a pretty common one. You should probably just memorize. It's going to give us an x root x, and this one is going to be y root y. Right? Whenever we have something cubed, it'll be that something times the root. So put it all back together. We have a 3, an x, and a y. outside the root, and a 2, an x, and a y inside the root. And that would be our final answer. Questions on those first two? Okay, third one. I'd simplify this one to be root 9 times root 10, or 3 times root 10. The root of x to the 6th is a perfect square, even power. That gives us x cubed. And then root y without an exponent, or an exponent of 1, we can't do anything with it, and that's going to stay root y. So, final answer, 3x cubed outside the root, root 10y inside the root. And last one, root 175 is root 25 times root 7, which is 5 root 7. The root x we can't do anything with. And the root y, we can kind of start to break that down by subtracting 1 to get that even power, root y cubed, which is, or root y, I keep saying that, root y to the 6th, which is y cubed, and then our root y. Put it all back together. We have a 5 and a y cubed outside the root, and then 7xy inside the root. Okay? This is one of those things where it's kind of difficult to see how you get from your original expression to your answer, even though they're the exact same value, to where if you plugged in anything you wanted to for x and y, the root of 90x to the 6 times y would be the same as 3x cubed root 10y, right? These values are the same thing, but it's difficult to see how you get to the answer from the beginning, which is why work's important. Because if you're looking back on this 2 weeks from now, when it's come time for the test, and you didn't show your work, it's tough to make that connection from beginning to end. So thankfully, you'll have a video up on YouTube you can watch and like and subscribe to help walk you through it. But yeah, some other math teacher's channel. No. 172. 172.
Should be like an incentive for
I always said the 200 mark would be when I launched my merch, but we're not there yet, so I don't have to worry about it. No. Okay. PO61 part 2. Remember the days when our denominators were perfect squares? Oh, those were fun. Whoops. Okay. So this is the next part, the next level of simplifying radical expressions, because now that we've done it, we've simplified fractions with perfect square denominators. We can talk about what do you do if your denominator is not a perfect square, okay? And the process is something called rationalizing the denominator, okay? Essentially, we are turning the denominator into a rational number. Because if we're given the fraction 5x over the root of 7, is the root of 7 rational or irrational? Think back last year to algebra. Is the root of 7 a rational number or an irrational number? Remember, rational numbers are anything, fractions, negative, decimals that end or repeat. Irrational numbers are decimals that go on forever. It's irrational. The root of any non-perfect square is irrational. I'll say that again. The square root of any non-perfect square is an irrational number. So something like the root of 7, it's mathematically illegal to have an irrational number in the denominator of a fraction and consider it simplified. The exception to that rule is if it's pi, right? If you have something like 3 over 2 pi and you write it in terms of pi, then it's okay. Other than that, the roots of non-perfect squares, no. Okay? So what we do is we multiply that fraction by that root 7 over itself. Okay? If we have the fraction 5x over root 7, to rationalize the denominator, to turn that denominator into a rational number, we multiply by root 7 over itself. Okay? 2 reasons why. Number 1, when you multiply by root 7 over root 7, what happens in the denominator? Root 7 times root 7 is the root of 49, which, what's the root of 49? A rational number, right? It equals 7. Okay? The other reason why we can do this is because the value of root 7 over root 7 is 1. Anything divided by itself is 1. So are we really changing the value of our original fraction? No. Okay? We're just multiplying it by something to eliminate the irrationality of it, if that's a word, in the denominator. Okay? That's all there is to it. It looks more complicated than it actually is. But if you think about what multiplying by that root does, and the fact that you're multiplying essentially by 1, okay, it tends to make a little more sense. So we've got 2 over root cubed, or sorry, root cubed. What am I saying? We have 2 over root 3. What are we going to multiply this fraction by to rationalize, to eliminate that root 3 from the denominator? This time it's not going to be root 7 over root 7. It's going to be, Peter? Root 3 over root 3. We can't just multiply by root 3 because now nothing's happening to the denominator, right? We have to multiply by root 3 over root 3. Okay? In our numerator, that gives us 2 root 3. We can't combine those to get like root 6 or something like that because one's outside the root, what's under the root. We have to keep them separate. And in our denominator, root 3 times root 3 equals the root of 9. We can combine those because they're both under a root. And the root of 9 equals 3. So 2 root 3 over 3 would be our simplified answer. But Schultz, you've got an irrational number in the numerator. We don't care about that. Okay? We don't care about that. It matters that you have a rational value in the denominator. 9 over root 5. What are we going to be multiplying this fraction by to rationalize? It's not going to be root 7 over root 7. It's not going to be root 3 over root 3. It's going to be root 5 over root 5. Okay? We're multiplying by a really kind of funky version of 1, so the value isn't changing here. And what happens in that denominator, root 5 times root 5, gives us root 25, which is just equal to 5. Essentially, those roots cancel out, is what happens. In our numerator, 9 times root 5, we can't combine them because one's under a root, the other one isn't. So we just have 9 root 5 over 5. Okay? Questions so far? Caleb?
You've been very nice so far with the denominators.
Thank you. What does that mean?
Or with the bottom numbers, and that they're all perfect squares.
Oh, up until now. Yes, now things change. Yeah. Do the next two on your own or with your table mate just to kind of get this process down. We'll touch base in another minute. All right. And we are back. Things look really good walking around the room. Most of you, in fact, everyone that I looked at got 8 root 15 over 15 for that one. Got either 1 root 10 or just root 10 over 10 for that one. Okay. Why can't we cancel out our root 10 and our 10 or our root 15 and our 15? Why can't we do anything more with simplifying there? Because awfully tempting when I see a 10 and a 10 and a fraction to cancel them out. Why can't I do that here? Do you know? Yeah, they're not the same value, right? Root 10 is not equal to 10. Root 15 is not equal to 15, right? They look like they might be cancel outable, but they're not. 6 over 3 root 10. Okay, we have some options here. Can we do any simplifying before we start? What can we simplify here? You can, if you want to, simplify the 6 and the 3 here, right? To give us 2 over 1 root 10 or just root 10. Okay? If you do that, multiply by root 10 over root 10, you get 2 root 10 over 10. Are we done? No, because we're going to simplify now. The 2 and the 10, right? Both are outside of the root. So that would give us a 1 root 10 or just root 10 over 5. Okay? Like a 1/5. If you didn't simplify first, let's kind of go back to the beginning here. If we don't simplify first, what is the only thing I have to multiply my denominator by? Or my fraction, I shouldn't just say denominator. What's the only thing that I have to multiply my fraction by if you didn't simplify first? What's the minimum thing I would need to multiply by here? Basically, what I'm asking is, do I have to multiply by 3 root 10 over 3 root 10? No, because nothing wrong with that 3. 3 is rational, right? You only have to multiply by what you want to remove. What I want to remove, or what I want to rationalize, is the root 10. Okay? If you do it this way, our numerator becomes a 6 root 10. Our denominator now, this root 10 times root 10 equals a 10, but I can't forget about my coefficient of 3. So my denominator actually becomes a 30. And what can I simplify now? Blake? The 6/30ths here, which simplifies to be 1/5, I still get that root 10 over 5. So the point I'm trying to make here is you don't have to simplify in any given order. You can simplify the fraction from the outright. You can simplify it at the end. It doesn't really matter, okay? As long as you do what's in the middle correctly there. Let's do one more together, and the rest will be homework for you. The next one? It's eventually, maybe not, maybe I shouldn't say this. Eventually, maybe, hopefully, there'll come a point when variables don't scare you, okay? But just like every other one that we've done so far, what do I want to remove from the denominator? Joey, the root x, right? So what am I going to multiply by? Not root 7 over root 7, not root 5 over root 5, not root 3 over root 3. Root x over root x. Right? Because it equals 1. And in my denominator, root x times root x is the root of x squared, which, looky there, a perfect square. Doesn't matter if it's a number or a variable or what. Okay? The same relationship here. Root 3 times root 3 equals 3. Root 5 times root 5 equals 5. Root 10 times root 10 equals 10. Root x times root x equals x. And my numerator, what do I get? Peter? Not the root 12x squared. Drake? 12x root x. Okay? Just like we saw in examples prior, if I've got something under a root, 9 times root 5, I can't combine them. 8 times root 15, can't combine them. Right? Same thing here. Okay? Yeah. Give the rest of them a go. This will be homework for tomorrow. You got 9 minutes to work on it now. 6 of them to do. The last one, like the 18x cubed. That one. This one, 2 root 10. Okay. How would you, folks, before you start, hold on. Question was asked about the last one here, the 2 root 10 over root 80. What would you think to do first here? That would make your life a little bit easier. Michael? Why can we do that? Because they're both under a root. Okay. What is the root 10 over root 80 simplified to be here? What is root 10 over root 80 simplified to be? Root 1 over root 8, right? You can think about it as the fraction 10/80ths. 2 root 1, we don't even need to write in the numerator because root 1 is just equal to 1. And so essentially, by simplifying, we can break this down to 2 over root 8 and simplify that. That doesn't work. All right. Okay. So simplifying first, Blake, maybe that's helpful. Now you only have that root 8 to deal with there. And you can even simplify that root 8 further if you wanted to, which makes your life even easier, but you can take it from there. Right? I heard someone say, how do I do this? That sounds like a good question for me. Figure it out?
What?
Did,
Oh, no, I haven't figured it out yet.
do you want to talk about it?
Yeah.
Which one?
The very last one.
The very last one.
Yes.
Okay. What did you do to start this?
What?
What did you do to start this?
Oh, I don't know.
Oh, okay. What are someone's thoughts for how to start the very last one here? What would you think to do first? Yeah, Peter? Okay. Even before we split it up, though. I mean, sure, that's good. Peter's saying, start by breaking this up into the root of 18x cubed over the root of 28. Since it is a fraction, deal with each one separately. You can do that. What else could you do before splitting up, though, Drew? You can simplify 18 and 28. That would be 9/14. So in your numerator now, you get 9x cubed over 14. Right? Wait, a root inside of a root? Is this man crazy? Actually, it wouldn't be a root inside of a root if you just simplified that. This man is a little bit crazy. Whoops. Okay. Now, when you would break this up into its numerator and denominator separately, you'd have the root of 9x cubed, which 9 being a perfect square is kind of helpful, over the root of 14. All right, these two things are essentially the same. One you simplified 10/28, the other one you didn't. Okay? So, you can take it from there. Simplify your numerator separately from your denominator. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms on this? Yes. Thanks. You too. Anything else? My mom watches these. Be nice.
For real?
She's my one like.
Did she actually do it?
I think so. I told her to. Maybe she doesn't. I don't know. Hi, Mom, if you're listening. Please do my laundry. Okay. All right, folks. Homework due tomorrow. That's how you math.